Hey friends, this is day 13 of our ratios unit, and I thought it'd be helpful to do a video for today, even though we're kind of just gonna continue going back over unitary method and equivalent fractions. But we have a quiz tomorrow, so I thought it might help some of you to have a video. So here you go. Okay, let's start with a word problem, and I think you might have some different names on your notes. That's okay. But your first one says, Mrs. Juergens used 2 packets of flour to make 15 cupcakes. How many can she make with 10 packets of flour? Well, first of all, that probably won't ever happen because, to be honest, I don't make cupcakes. But maybe one of Mrs. Juergens' daughters made cupcakes, so let's go with that. Okay, so we've got our bar model already set up there in front of us. And we want to figure out how many packets of flour I need, or how many cupcakes I can make with 10 packets of flour. So let's assign those 2 units to 10, solve for 1 unit, which is 5, and now we're going to solve for 15 units. So 5 times 15, I'm sure you guys all just did that in your head, means that I can make 75 cupcakes. All right, now we've got Mrs. Duroux mixing Kool-Aid and water in a ratio of 1 to 3 to make 1 kilogram of drink. Find the amount of Kool-Aid mix used. Write your answer in grams. Okay, so that's really key, you guys. Whenever you have one of these word problems where you have kilograms, it's just going to make your life so much easier if you convert to grams. And actually, as soon as I said that, I realized I probably can't make a generalization like that. So I shouldn't say whenever, but I'd say for the most part, usually your life will be easier if you just go ahead and convert that to grams. So you should remember that 1 kilogram equals 1,000 grams. So we're going to assign all 4 units to that 1,000 grams because we made 1 kilogram of drink. So right here in your word problem where it says 1 kilogram of drink, that means that all of the ingredients were utilized to make that 1 kilogram. And we want to solve for 1 unit. 1,000 divided by 4 is 250. And so Mrs. Duroux used 250 grams of Kool-Aid to make her Kool-Aid drink. Okay. All right, so now we have a perimeter problem. It says the ratio of the length of a field to the breadth is 5 to 2. Find the perimeter of the field if the length of one side is 45 meters. Okay, so, whenever we have one of these perimeter problems, we have to go all the way around the field or the garden or whatever it is, right? So just like that. So we have 5 units going this direction. We have 2 units up, and then we have 5 units here, and then 2 units down. So all together, we're going to have 5, 10, 14 units that we're going to solve for. So let's first solve for 1 unit. So we have 5 units that equals 45 meters. Then we're going to solve for 1 unit. So 45 divided by 5 is 9. And then we're going to solve for 7 units, and then we're going to double it. So let's do 9 times 7. And that's, of course, 63. And then, of course, we need to double it because we're going all the way around the perimeter, not just around 2 sides. 63 times 2 is 126 meters. So Jack's savings is 1/3 of Mary's savings. If Mary saves $70 more than Jack, how much do they save together? So this word problem you need to read pretty carefully. So let's just talk through how we set up our bar model first. Jack's savings is 1/3 Mary's savings. So that means I gave Jack 1 unit, I gave Mary 3. If Mary saves $70 more than Jack, that means these 2 units right here that she has more than Jack equals my $70. How much do they save together? And I want to solve for all 4 units. So 2 units is $70. Solving for 1 unit, 70 divided by 2 is 35. And now we're going to solve for all 4. And I bet a lot of you can see that we probably could have skipped that step of solving for 1 unit and just doubled that original 2 units, but that's okay. We're going to do the whole thing. So 4 units is 4 times 35, which is $140 altogether. There are 4 times as many boys as girls in a school band. If there are 12 girls, how many more boys than girls are there? So we've got our model drawn there where we've got 12 assigned to our 1 unit of girls. I hope you could see that. We set this up with 1 unit of girls and four of boys, because it says right here in our word problem that there are 4 times as many boys as girls. So we assign that 1 to 12, and we want to solve for 3 units. So if 1 unit equals 12, 3 units equals 3 times 12, or 36 more boys. Okay, so the last couple word problems on your page, we're going to solve 2 different ways. I'm going to solve it using unitary method first, but I'm not even going to bar model it, just because we really don't need to with this one. And then I'm going to show you how to solve it using equivalent fractions or proportions. Okay, so Evan can type 80 words per minute. How many words can he type in 10 minutes? So let's just set this up with 1 minute equals 80 words, right? So this is basically unitary method. And now we want to know how many words he can type in 10 minutes. So 10 minutes is going to be 80 times 10, or 800 words. Now the second part of my problem says, how long will he take to type a passage which contains 2,000 words? Okay, so we have 80 words, which equals 1 minute, right? And if we solve that for unitary method, we're going to break that down and divide both sides by 80, and we would get 1 word equals 1/80th of a minute. I am not going to do that division and convert that to a decimal. We would leave that as a fraction just like it is, because you know in just about a second I'm going to multiply that times 2,000. So when I do that, I multiply both sides by 2,000. I get 2,000 words equals 1 over 80 times 2,000 over 1, which equals 2,000 over 80. And if we divide those by 10, we can divide that fraction by 10 and get 200 over 8, which is 25 minutes. So I know some of you were kind of digging the equivalent fraction things last week, and so I'm going to show you how to solve this problem using equivalent fractions. Hopefully you have paused it and are already trying to do that yourself, but just in case, let's just do this together. So how many words can Evan type in 10 minutes? So we've got 80 words per 1 minute. Now this is the first time I think you've been introduced to the fraction bar, meaning per, and that is one of the meanings of the fraction bar. So when we were setting up our proportions last week as fractions, and we were talking about, 4 out of 3 or 3 per 5 or whatever, the fraction bar can mean out of and it can mean per. So in a rate like what we have here, it means per. Okay, so 80 words per 1 minute equals something, some number of words in 10 minutes. So I'm going to just look at this and ask myself, what did I do to that 1 to get 10? And I'm going to do the same thing up there. So clearly I multiply that 1 times 10, right? So obviously I need to multiply that 80 times 10, and I'm going to get 80 words in 10 minutes. Okay, so now I want to know, how long will he take to type a passage which contains 2,000 words? So I'm going to do the same thing. I'm going to set up 80 words per 1 minute, and I'm just going to fill in my other side here. So I want to know how long he took for 2,000 words. So now I have the words, but I don't have the time. So let's see here. So basically, I'm going to do the same thing though. I'm going to ask myself, what do I do to this 80 to get to 2,000? And I'm going to do the same thing on the bottom. So we know that 80 times 25 equals 2,000. And if you didn't know, like for example, if we didn't just solve this exact same problem, we could do some division over here, and we could divide 2,000 by 80. I would just start by crossing off those zeros and dividing both sides by 10, or both dividend and divisor by 10, and then I would divide 200 by 8, and I would get 25 eventually. There we go. Now you can see it. Okay, so I'm going to multiply 1 minute times 25, and I'm going to get 25 minutes as my answer. So I liked this problem more, doing it with equivalent fractions. I think it's easier to use the equivalent fractions than it is to use the unitary method on this particular problem. And so that's why I wanted to demonstrate it, and I want you guys to be flexible with both methods so that you can look at a problem and reason about it and decide what the best way to solve it is. And there are always multiple ways to solve problems, and that's great. That's fine. So if you can solve it even with more than one method, you get like bonus points. I mean, not really, but you can give yourself some in your head. Okay, so that's it for day 13 ratios. If you were ill today, your homework is called Day 13 Review Homework. That's the heading at the top of the worksheet. And we have a quiz tomorrow.